Wind shears through the trees. Thunder shakes the ground. A violent thunderstorm at night is chaotic, erratic, and aggressively loud. Accounts spanning centuries describe these glowing orbs hovering a few feet above the ground, radiating harsh white, blue, or vibrant orange. Ordinary electrical discharges in the atmosphere flash and vanish in a fraction of a second. This object ignores that rule, gliding deliberately and steadily through the chaotic air. Despite consistent, localized reports from all over the world, modern atmospheric science has no universally accepted explanation for what is creating this structure. An ordinary lightning strike is a massive, instantaneous release of electrical energy, plunging downward to equalize a charge. It illuminates the sky and disappears instantly. Ball lightning inexplicably holds its form, lingering for several seconds while maintaining a constant luminosity. This diagram compares the physics of the two. On the left, standard lightning follows a jagged vertical path straight into the ground. On the right, ball lightning maintains a smooth, contained, horizontal trajectory. Reports routinely place these spheres in densely packed, obstacle-rich environments. They are seen weaving through trees, maneuvering around buildings, and hovering near complex electrical equipment. A floating sphere of concentrated charge presents a severe physical contradiction. Raw electrical energy should immediately ground itself upon contacting any surface, or quickly dissipate into the surrounding open air. For an object to remain electrically active and physically cohesive in an open environment, it must bypass the established laws of electrical dissipation that govern every other known atmospheric discharge. Researchers have proposed several mechanical models to explain the anomaly. The first relies on chemical vaporization, suggesting the phenomenon is born from the ground up, not the sky down. A high-energy bolt strikes mineral-rich soil, transferring immense heat underground. This thermal shock vaporizes the soil's minerals, ejecting a plume of glowing particulate matter into the air. These suspended particles then condense into a cohesive, floating spherical cloud, drifting on local air currents. The fatal limitation of this theory is the environment. This reaction requires very specific soil compositions, which completely fails to explain identical glowing spheres observed high in the clouds or over massive bodies of water. While chemical reactions explain how a sphere might form near the ground, they do not account for the full range of sightings that science has yet to reconcile. That requirement leads researchers to a more complex physical hypothesis: atmospheric plasma. Plasma is an intensely charged state of matter where atoms are stripped of their electrons. It fuels the sun and flashes in brief electrical arcs, but it is extremely rare as a free-floating entity on Earth. A severe thunderstorm generates intense, chaotic electromagnetic fields. Under highly specific conditions, those fields might compress atmospheric gases into a concentrated pocket of this charged matter. The challenge here is basic thermodynamics. An unrestricted pocket of plasma naturally wants to expand violently and cool down almost the instant it forms. To keep this volatile atmospheric plasma spherical, an unknown containment mechanism, like an invisible electromagnetic boundary, must constantly exert immense inward pressure. If these orbs are truly free-floating plasma, nature is generating a self-sustaining energetic structure that physicists currently struggle to replicate outside of highly controlled laboratory vacuums. Pinning down the exact physics requires hard data, but the phenomenon presents an extreme methodological roadblock. Ball lightning offers absolutely zero geographic or temporal predictability. Researchers cannot deploy sensor arrays or schedule controlled experiments for an event that appears and vanishes without warning. Without dedicated instruments in place, scientists are left evaluating alleged photographic evidence. They must filter out lens flares, camera optical distortions, and distant glass reflections that perfectly mimic a glowing sphere. After filtering the artifacts, the remaining data relies almost entirely on subjective human memory. The lack of replicable data traps the phenomenon in a frustrating space between anecdotal observation and rigorous science. While the physics remain theoretical, historical records document a very real physical interaction between these anomalies and their environment. Eyewitness accounts detail severe local damage, ranging from scorched earth and structural fires to significant interference with modern power grids. A stationary electrical threat is dangerous but predictable. A sphere of concentrated energy moving horizontally on shifting air currents presents a uniquely terrifying and erratic hazard to anything in its path. Because its exact energy density and trajectory cannot be predicted, ball lightning remains a poorly understood hazard that complicates the safety of already dangerous storm environments. We possess high-speed imaging systems, advanced sensor networks, and immense computational power, yet no scientific body has successfully captured and analyzed a single instance of this event. Chemical vaporization and trapped plasma remain compelling models, but neither has claimed definitive victory in the scientific community. The vast discrepancies in size, color, and behavior suggest a radical convergence. Ball lightning might not be a single event, but an umbrella term for several completely different, undiscovered atmospheric anomalies that simply look identical to the human eye. Somewhere, during the very next powerful storm, another glowing sphere will form in the rain, exist for seconds, and vanish unseen. Ultimately, the phenomenon suggests that the atmosphere is capable of producing structures that our current sensors and simulations are not yet equipped to explain.